My dear students, I welcome you all to this new video, LCM, lowest common multiple. Why is this lowest common multiple? Is it that I don't know about the lowest common multiple LCM to find out LCM? No, you know this concept. Is it that it's very tough? No, it's not that tough. It is very easy. Then why is this video? Let's follow this and understand. Okay, fine. What I tried this time is I went for a mind map. Lowest common multiple. Please forgive me because I'm not a very good artist. I couldn't write very neatly with very colorful, but then I've tried my bit here, keeping the concept of mind mapping. Yeah, lowest common multiple. Something which is lowest common, it means when I say something is common, it means always that I'm comparing with something else. Otherwise, why would I say it as common? Right? Multiple. What do I mean by multiple? Something which comes in the multiplication tables. We know our multiplication, so something which comes in the multiplication tables. So now let's take this as a number which is common in the multiplication tables and it is the lowest. For example, if I take 14, 14 is a common number in 2 and 7. Got it? And this is there in multiplication table and it is supposed to be the lowest. The one which is present both for 7 and both for 2 tables. Correct? Yes. If you understand this, let us go for some more details of it. Is it common? If you observe the mind map here, I have given one main root. Is it common? Yes. How many numbers? I said at least 2 numbers. I said at least 2 numbers, but I am not limiting it to 2. It can be anything more than that. How do I work on this? By the multiplication tables. Right? Okay, so what are the mostly used operators in finding out LCM? It is plus and minus, correct? Yes, so now I am directly taking you for an example. Yes, so here I said multiplication table. So let's look for the multiplication tables. We have 3, 6, for the multiplication table 3, 6, 12, 15, 18, 24, it just goes on. And then for 4 also, 4, 8, 12, 16, 20, 24. Here among the multiplication tables, I take one number which is common in both of 3 and 4. What is common? If you just observe these two tables, 12 is common. Is it the lowest? Yes, compared to 12 and 24, 12 is lowest. Sorry, it is lowest. So, can I take 12? Yes, you are ready to take 12. That becomes the LCM between 3 and 4. Oh, okay. If that's the case, what are the type of the numbers that usually I work with or where I require LCM? My dear friends, this is mostly used in fractions. When we want to add fractions, we get confused. Will not have the clarity when we are working with the fractions as we are having the clarity of our direct addition and subtraction. For example, 2 plus 3 is dead easy for us. We say it is 5. The same thing, 1 by 2 plus 1 by 3 is not that easy. Then what is the root? Is by finding out the LCM. Okay. Then in the mind mapping also, I have one example. So you take it if it is required, or let's go deeper down to the examples here. Okay. Yes. So this is a working one. Let me repeat the lowest common multiple concept again. Common among the multiplication tables. Then how many numbers I should be comparing with? At least 2 numbers. What is our methodology of working? That will be through our multiplication tables and directly go for this example 3 and 4 tables. So the lowest and the common one among the tables 3 and 4 was 12. So I just took them. Where exactly do you find the need or necessity of LCM? It is in our fractions. For example, it is, I have given you 1 by 3, 5 by 3, 2, 9 by 27, like that. Then on the left side, yes, I have given you a direct concept of LCM or a direct working of LCM. Now let's go down. Here here I will go for the example 1. I will say what is 1 by 2 plus 1 by 2. If I say 1 by 2 and 1 by 2, probably it is not that easy to understand. If I say half and half, half apple plus half apple, take half apple and take another apple, club them together, it becomes one full apple. That is very easy for us to understand. Half apple plus half apple is one apple. The same thing, half plus half is 1. How do we get that? Let us look that through our LCM concept. Now take the LCM of 2 and 2, which is 2. Why the LCM of 2 and 2 is 2? Here the numbers for which we are going to find out the multiplication itself is 2. Among the numbers 2, which is the lowest one, is 2 only. So take that LCM and start working. Now you got the LCM as 2 for both of these fractions. So you divide the denominator of the first fraction, that is divide the LCM we got was 2 and divide it by 2, you get 1. 1 into its numerator is 1. Again the same thing goes for the other one. So it becomes 1 plus 1, which is 2 by 2, which is 1. So probably rather than me going for this example, let me go for the other example. And also I have detailed the steps here. There are 9 steps which I have detailed. If you follow these 9 steps, it is damn sure you will not get into any confusion anywhere. Right? Now I will go for 5 by 8 minus 4 by 9. Okay, so say, no, before that I had 5 by 8 plus 4 by 9. So here the numerator in the first fraction was 5, denominator was 8. Numerator in the second fraction was 4 and denominator was 9. Now for whom should we find out the LCM? It is for the denominator numbers and not for the numerator numbers. First bear this in mind. To whom are we finding the LCM? For the denominator numbers 8 and 9. For 8 and 9, if you, don't go for your LCM, how to find out LCM concept. Let's just understand for 8 and 9, what will be the lowest common multiple which comes both in 8 and both in 9. So if you just observe, 8 9s is 72 and 9 8s is 72. Before that, did we have any other common number? No. After that, do we get common numbers? Definitely. But then where is our focus? On the first common number, which is least among both of these tables. Which are those tables? 8 and 9. How did we get this is 8 and 9? Because they are the denominators in these fractions. Now you got the LCM as 72. Then go for divide 72 by the first denominator, the first fraction's denominator, which is 8 by 72, which is 9. I have put it here. Then multiply this by the first numerator. Okay. Next, then what's the sign we have? Take the same sign, minus. Then the same rule or the same step goes for the second fraction also. In the second fraction, take its denominator, which is 9. Divide 9 by 72. Yes, you got the quotient as 8. Then 8 into the numerator is 4. Okay. So it is 9 into 5, 45, minus 4 into 8 is 32, divided by 72, which you get it as 13 by 72. So there is nothing more to explain here in LCM concept. So what I have done is I have derived some steps for it. Alright. Let's go for the steps. Look for the tables of the denominators given in the problem. From step 1, get the common numbers. Where is that? From this step 1, get the common numbers. Take the lowest of them. This acts as the common denominator for all the fractions of the given sum. Now let me take you to the second example here. So take the lowest of them. We got it as 72 is the latest, and this acts as a common denominator for all the fractions in that sum. Yes. Divide the lowest common multiple, that is that LCM, by the first denominator. What was the first denominator? Which was 8. Done. Multiply the obtained quotient from step 4. From step 4, what was the quotient obtained for the first fraction? It was 9. On dividing 72 by 8, we get 9 into the numerator and the first fraction, which was into 5. Then repeat steps in 5 for rest of the fractions as given in that question. What is the rest of the fraction given? It is 4 by 9. So repeat the same step. LCM we got as 72, divided by 9, which you get the answer as 8. 8 into 4 is your 32. Next, the denominator is LCM obtained in the step 3, and from all the fractions, as we see in step 7, from all the fractions, the product obtained after multiplying the quotient and the numerator will be added together from all the fractions. Let me repeat again. We had two fractions in the above examples. What are those? 5 by 8 and 4 by 9. From these fractions, whatever the product you got after you multiplied the quotient and its numerator, they will be added or subtracted accordingly as whatever is given in that question, in that problem. Then we will be getting the final numerator. And then what happens to the denominator? That itself is nothing but the LCM. Then divide the numerator and the denominator separately. This will be your final result. Now, let me repeat again for example 3. First one, look for the tables for 8 and 9. Done, which is 72 that we got. From step 1, get the common numbers. Yeah, the common numbers was 72. Next, take the lowest of them. This acts as a common denominator. Yes, we already did it. Divide this LCM by the first numerator, first denominator. You are dividing it by 8, which we got the answer as 9. And then go for the fifth step, where we are multiplying the numerator with the quotient we got. The quotient was 9 and we multiplied it with 5, which was 45. Do the same thing for the second fraction. In the second fraction, we have the denominator 9. You divide 72 by 9. We get the answer as 8. Now multiply it with its numerator, 8 into 4, which is 32. So 9 into 5 is 45 minus 4 into 8 is 32, which is 13 by 72. And having said this, with the completion of these steps, I will say these LCMs are mainly used when we are going for addition or subtraction of the fractions. Got it? And when I said addition and subtraction of the fractions, we should be thorough with the multiplication and division. Yeah. So having said this, I request you all to practice these 5 questions and show it to me in the class. Thank you.